to Hotel Bar Sessions, the podcast where three philosophers sit down at the end of a long conference day to chop it up at the hotel bar, which, as we all know, is where the real philosophy happens.
Welcome back, everybody, to Hotel Bar Sessions. I am your host, Charles Peterson, and I'm sitting here with my two vainglorious co-hosts, Dr. Liam Johnson and Dr. Richard Lee. Today we're talking about algorithms, that interesting little thing in their intertubes that sort of explain what's going on and give you some feedback. As you can tell, I'm an expert. But before we do that, let's get some drink orders and let's get a rant or a rave. Rick, what are you having?
Noel, I'll have a Tom Collins classic cocktail. Again, I'll let you choose the gin. I just don't want well gin. Today, I'm in a raving mood, and I'm going to rave about the Martin Short character, Jiminy Glick. Every once in a while, I go down a YouTube rabbit hole where Jiminy Glick, that character just brings me out of whatever doldrums I have found myself in. So look it up. You could watch hours and hours of Martin Short playing Jiminy Glick.
All right. Lee, what are you having?
Today I'm going to mix up my drink order a little bit just to throw off the predictive algorithms that are tracking me at bars. And I am going to have a amaretto sour.
Oh.
Today I am ranting about meetings without agendas. That will definitely confirm all predictive algorithms about my behaviors and preferences. I'm sure that doesn't surprise you, but it drives me crazy. If you're going to call me to a meeting, let me know I'm going to be there before I'm there. What about you, Charles? What are you drinking and what are you ranting or raving about this week?
You know, I'm just going to have a beer. I'm feeling a little working class-ish, so I'm going to have a cold style. Today, I am raving about Brother Theodore. Brother Theodore is a character from the early days of David Letterman's night show. He was a performer from the 60s in the West Village, and he just had this character of really manic, insane, super intense sort of Eastern European intellectual. And I loved him because his use of language and the absurd really opened up the door for the absurd of my 12-year-old mind. So I'm just thinking back about Brother Theodore. If you get a chance, go on YouTube and look at all of the footage from those early days with David Letterman. So it seems that Dr. Liam Johnson is in the hot seat today. Lee, take us by the hand.
Well, today we're going to be talking about algorithms. And I just want to set it up this way. In my classes over the last few years, I've been trying to emphasize the importance of digital literacy, which I think is today as important as actual literacy. And one of the things that I realized is that the engine of the internet right now, which is really algorithms, is something that a lot of people just don't understand. I think that people know the word algorithm, and I think that they know that it does important things. But I think that if you asked most people to explain what an algorithm is, how it works, and what it does, that they couldn't do it, and it's just a word that they use because they don't want to say that the internet is magic, but they believe it's just magic. And so I think it's really important for us to talk about algorithms. What are they? What do they do? And what might be some problems with how they're being designed. Algorithms are everywhere. They're making increasingly important decisions about everything from how we get information to whether or not we get loans, what sorts of medical treatments we get, how long our sentences are if we ever find ourselves in the unfortunate situation of being sentenced. There's a lot of things to talk about. So I want us to talk about not only what algorithms are, but whether or not we can design them in more ethical, human-centered ways.
So, Lee, it sounds like what you're saying is algorithms are to popular understanding as germ theory is to popular understanding during the Middle Ages?
So, Charles, what you're asking is, in the Middle Ages, when the plague came around, they thought this was all sort of hocus pocus. And so rather than like isolate ourselves from one another, we'll just burn incense or cover ourselves in cold cloths. And we're relating to algorithms in the same way.
Pretty much. Yeah, I think that's it.
I mean, I kind of like this analogy. I think it has similarities and differences. So it is similar in the sense that the effects of algorithms are things that we experience in our lives, and we understand the experiences that we're having, but we don't understand the relationship between algorithms and those experiences. I think it's dissimilar in the way that I'm assuming during the plague, people didn't have the word for germs, where we do have the word for algorithms. So we can at least point to the cause without actually understanding what the cause is and the relationship between the cause and effect. So maybe, and I know this is going to shock you, we should just start with the definition of what algorithms are.
For once, I wholeheartedly agree with you. Please. Please.
Okay, an algorithm is just a set of instructions. So a recipe is an algorithm. A map can give you an algorithm for getting from one place to another. But when we talk about it in computers, we're talking about a set of instructions usually for executing some kind of a task. So algorithms have been around for a long time, since before computers. Algorithms today, though, are much more sophisticated than, for example, what you would find in your grandmother's recipe book, right? So there are all different kinds of algorithms that are used in computer engineering to basically turn data into models, either predictive models or models that recognize patterns or models for accomplishing specific tasks. And like I said, there are all kinds of algorithms, depending on what you want to do, that are used. So there's logistic regression, linear regression, decision trees, this kind of weird thing that uses a group of decision trees that they sometimes call random forests. There's KNNs, which stand for K nearest neighbor. There are naive Bayes algorithms. There's a lot of different algorithms. Now, when we talk about machine learning algorithms, they're even less straightforward than algorithms in the normal sense that we would talk about it, because the mathematical functions that are being executed are embedded in so many layers of algorithms that it often is very difficult, once the output comes out, to understand how we got from the input to the output, right? So we understand the data that we're putting into the algorithm, we understand the model that's coming out on the other side, but we often don't understand how we got from the data to the model. That's what sometimes is called black box AI. We have a operation that is so complex and is using such massive amounts of data in so many different layers of neural network computing that the human mind quite simply can't really understand all of it.
Just a quick clarification question. So you mentioned machine learning, and would it be a good definition of machine learning to say that it is the training of an algorithm to recognize something, perform a certain task, select certain things on the basis of a set of data that's fed in that it could look at, to use that as a metaphor, to then learn on its own, as it were, how to recognize patterns, how to make decisions, how to recognize behavior, and so on?
Yeah, I think that's a really good description. And it's also probably important to know that there are different kinds of machine learning, right? There's supervised learning, there's what's called unsupervised learning. And then we have neural network learning, deep neural network learning. And obviously, these get more complicated as they involve more and more complex learning algorithms. It's probably also important to note that, and maybe this is obvious, but I don't think it's obvious to everyone, that there's no such thing as clean data in the wild, right? In order for data to be useful for machine learning, it has to be aggressively filtered. And now we're kind of getting into what I think is really important about understanding algorithms, is that algorithms, as Cathy O'Neill, the author of Weapons of Math Destruction, describes them, algorithms are opinions embedded in code. So the idea that the data that we put into machine learning systems is objective, or the models that we get out of machine learning systems is objective, or even that the algorithms themselves are objective, is false.
So, this is my inner 4-year-old back again. Hello, everyone. I am understanding algorithms as functioning as interlocutor, that it takes the data, that it translates it in a particular way, and then you get the end result on the other end of that. And it's interesting to me when you speak about there's no such thing as clean data. I think about algorithms being organized or configured in such a way as to screen for certain types of data, but maybe even also select for certain types of end results. Am I making any sense with that? Or should I just go back to the sandbox?
One of the things in what Charles said that I'm having a difficult time applying to algorithms is the interlocutor part of it, because it seems often that we do think we're in an exchange with an algorithm, whereas I'm not sure that algorithms are dialogue partners. I think they're a set of instructions that is somewhat different than listening to me and saying, oh, Rick, that's interesting. Let me think about that for a second. And so in that sense, I'm not sure that we interlocute, if that's a word, with algorithms.
I might also say that algorithms are also not the interlocutor between the data that goes in and the models that come out. And here it might be helpful, again, to return to the example of a recipe. If you have a bowl of milk and some flour and some eggs, and you make a cake, you wouldn't say that the recipe is the interlocutor between those ingredients and the cake.
All right, so let me do this. I will see your interlocutor and raise you a configurer. So you're right. My use of interlocutor was not the proper word. I'm thinking about it as a mechanism by which the data gets configured into a particular form, which may be closer to your metaphor of the recipe.
I think that Lee was pointing out earlier the ways in which there is a configuration of the data that goes on before the data is even put into the algorithm. And I think that often in the popular understanding, we think that the data as such is neutral, or as Lee put it, clean. And then the algorithm goes to work on that. And one question we need to ask in relation to algorithms is, how is that data prepared so that it could be put into the algorithm? A way to put this is, if we go back to the recipe, Lee says, I have eggs. Yeah, but you know what? I have to crack those eggs and get them out of their shell. So there's a preparation of a datum that is going into the algorithm, namely the recipe, that I think we do well to focus on. How is that preparation taking place? What are the values that belong to the choices of preparation, and so on?
I think it's probably also important to note that sometimes algorithms are designed in such a way that they often produce things that the designer of the algorithm did not intend, or they produce things that the designer of the algorithm could not have anticipated. And this can be good and bad, right? So this is one of my favorite examples, which I think is hilarious, but is actually a really good example. So there was a television series on HBO called Silicon Valley, which was about these young computer engineers in Silicon Valley. One of the computer engineers was trying to design an app that would be, as he described it, a Shazam for food. So for those of you who don't remember Shazam was an app where if you were in a restaurant and there was a song playing, you didn't know what the song was, you could just turn the app on and it would recognize the song and tell you the title and the artist of the song. He was trying to design one of these for food so that you could take a picture of food and it would automatically recognize what food it was. But when he designed the app, it would only answer hot dog or not hot dog. That's the only identification that it was able to do. It was only able to group things into two categories:
more do you need
hot
to
dogs
know?
or not hot dogs. So one, here's an example of a way that a poorly designed algorithm could not actually do what it was designed to do. However, what they realized was that this algorithm had another possible use, namely to filter out dick pics, right? Like you could have it on your phone, and when you got a pic in your DMs, it could basically identify hot dog or not hot dog, right? So this is actually not uncommon right now, and I think this is one of the things that we really have to be more sensitive to when we talk about algorithms, is that because they're learning systems, because they are involved in intelligent systems, that they're not tools in the same way that we generally think about other tools.
So, Lee, let me ask you, does it make sense for us to separate out two moments of complexity? The one that you pointed out, and I think this is Kathy O'Neill's point, comes in the making the data clean and the selection of the data and how one prepares the data. And as the sets of data become larger and larger, there's going to be an automatic complexity there. And then the second is the complexity that belongs to algorithms themselves. And that could emerge in two ways. One is that the larger the data set an algorithm has to deal with, the more complex the algorithm will have to be. But secondly, we're thinking of more and more complex ways to design algorithms so that we could get more meaningful in whatever sense the engineer understands what is meaningful.
Which is always going to be efficiency and optimization.
Exactly. One form of complexity emerges just from the ever-increasing size of the data sets, but the other form of complexity comes in that my algorithm itself has to be more and more complex as I'm asking computers to do more and more sophisticated tasks, perform more and more sophisticated analyses, and maybe even make decisions so that I don't have to or that are helpful in my life. So does it make sense, in short, to separate out the complexity that emerges from the data selection process and then the complexity that emerges from the algorithmic construction process?
Yeah, I mean, I think both of those things are really important, but just on the data selection side, and this is a relatively recent and still ongoing debate in data ethics, is that we have to understand that more precise and more accurate and even more so-called objective data can't fix a bad system. So even though the data may be accurate, the system itself, and this gets to the second sense of complexity that you're talking about, the system itself may lack the proper context for that data that would be able to situate its systemic implications. As an example, people talk about digital redlining. So we all know what redlining is, right?
Yes, red lines were established to circumscribe communities of people of color, primarily black people, and they would be designated as not viable for mortgages, whereas outside of the red lines, predominantly white institutions or white neighborhoods, those homeowners will be granted loans to purchase.
Right, exactly. And so now what we're seeing is a digital form of redlining, where persistent racism, which arises out of implicit bias or other factors, has influenced past terms of credit. And so we all know it's much harder to keep up on a loan at 15% interest than it is at 5% interest. Late payments are going to be likely, and then those are going to be fed back into the present scoring models as neutral, objective, non-racial indications of credit worthiness. So the algorithm today that decides whether or not you can get a loan actually is prescriptive, though the banks issuing those loans view it as merely predictive, right? Predictive of credit worthiness. And people want to say that, well, but if we just had more precise and accurate and objective data, that we could fix what is a bad system. But the problem is that you can't erase these things like implicit bias from even the most objective sounding data. And what ends up happening in real life is that banks end up using proxies. They use zip codes as basically a proxy for race. And so the same thing happens all over again. That's a really long and roundabout way of getting to Rick's distinction of these two levels of complexity, but I think it's really important to note.
And this is so amazing because one of my favorite podcasts, the Planet Money podcast, they have started Planet Money Goes to the Movies or something, and they bring on a guest and they decide on watching a particular movie and then they talk about it. And just 2 days ago, Lee, the guest they brought on was Kathy O'Neill, who was a host of this podcast, and the movie they talked about was It's a Wonderful Life. As a part of this discussion, she started talking about the origin of FICO scores, right? So credit scores. Right. That in its origin, it was an attempt actually to be a more neutral algorithm for deciding creditworthiness. Then it was discovered that there are implicit biases in the FICO algorithm itself, and a number of companies and engineers decided to find a way to judge creditworthiness in other ways. And what they decided to do was base an algorithm on one's what used to be called social graph. So look at your Twitter feed, look at your Facebook friends, and so on, as a way to get around the biases of the FICO score. And lo and behold, it turns out that the people who are most creditworthy are white rich men on this new algorithm. And so she was using this as an example to point out exactly what you're saying. Even if we understand that the engineers went into this construction of this new credit algorithm with all of the best intentions, their own social context, their own individual context is going to be present throughout the selection of the data and the construction of the algorithm and will produce biased results.
Hey listeners, before we have too many drinks and it slips my mind, if you can't catch us at the hotel bar, you can catch us on Twitter at Hotel Bar Podcast. You can also follow our HBS hosts individually on Twitter to catch their off-air thoughts. You can follow Charles at C_F Peterson. And Peterson is with an O, not an E. O, not an E. Rick is at Rick Lee Philos. That's Rick Lee with 2 E's and Philo spelled like half of the word philosophy. And Lee is at Dr. Lee M. Johnson. The doctor's abbreviated, and Lee spelled Leigh. Now, back to our conversation. So Rick leaves us with a really interesting point in terms of the biases of the engineers that are constructing algorithms and the way in which those biases are affecting the data that's being inputted. So can we talk about some of the problematic examples of that, Lee?
Oh, there's so many. So yes, we can. It's like where do I start?
It's a world of fucked upness. Here we go.
It really is. It's a whole hot mess. We got a dumpster fire here. Yeah. Let me just pick one of my favorite examples. There's this algorithm that's called COMPASS. It's an acronym. It stands for Correctional Offender Management Profiling for Alternative Sanctions. COMPASS. It's an algorithm that's used in sentencing guidelines in many states. So it's been used, I know, in New Jersey, of course, in Florida, and several other states. And basically what it does is it tries to judge the likelihood that an offender will reoffend, and, of course, suggests longer sentences for people who are more likely to reoffend and shorter sentences for people who are less likely, according to this algorithm, to reoffend. Now, it's not hard to see what kind of data we would feed into this algorithm in order to get models of who is more or less likely to reoffend. We're obviously going to be feeding in data about arrest records. And so it uses things like race, age, prior convictions, income, etc., to determine who's going to be more likely to offend and who's going to be less likely to offend. So ProPublica, which is a nonprofit investigative journalism outfit, looked into the Compass algorithm. And I say looked into with scare quotes around it because it is a proprietary algorithm. So they can't actually look at the algorithm, but they can look at its results. And they were able to clearly demonstrate that the Compass algorithm is disproportionately prejudiced against people of color, younger people, and women.
Quelle surprise.
Yeah, right. Hold on to your hats, boys.
Did not see that one coming. Did not see that one coming at all.
And I mean, obviously, there are lots of other algorithms we could talk about. We could talk about search engines. We could talk about facial recognition. We could talk about creditworthiness, algorithms, et cetera, et cetera. But like, here's something that I think is the most obvious in terms of its real life effects. It's like, how long are you going to go to jail, or how much are you going to be fined, et cetera. And it seems to me that this is where a lot of people don't realize how little control we have over the control those algorithms have over our lives. Like I said before, this Compass algorithm is a proprietary algorithm. It belongs to a company called Northpoint. They're not allowing anyone to actually look at the algorithm. And so all we can do is deduce from its effects that the algorithm itself must contain some implicit biases. But it can't be audited. It can't be rewritten, right? Unless Northpoint opens it up and allows someone to do that.
I think there's an important point that you just made, Lee, namely that on the one hand, these questions are questions of computer science. So computer scientists will look at various ways of constructing various algorithms to make things more efficient. If it's a decision algorithm, to make the decision point clearer, to make it so that it produces the fewest possible mistakes in the decision, and so on. But what you're pointing out is we have come to a point now where algorithms are, first, pervasive in our lives, and second, are being used in ways that affect whether we go to jail or not, whether we get a mortgage or not, whether we go to college or not. And this would be sort of a fascinating theoretical question for computer scientists if these algorithms weren't so frequently used in important decisions for the ways individuals live their lives.
It's so striking to me how at every single point of some degree of complex decision-making, these algorithms have been inserted into the functioning of our society. And we're talking about the problematic examples of this, but it's certainly frightening. Thinking about the ways in which, despite the hope or the claim that these algorithms will establish a much more objective way of determining or assessing data, it's just a replication of the same types of, as Rick said at the end of last segment, the biases that accompany those who are in a position to construct algorithms.
Yeah, and I mean, in that sense, that structure very much imitates the structure of bureaucracy, as, for example, Weber described it. We want to remove human biases from decision-making processes as a part of this overarching pursuit of efficiency and optimization. So bureaucracies are put in place so that no individual person's biases can affect a larger system. The bureaucracy is there, and the rules of the bureaucracy remain in place even as bureaucratic officials change identities. But the problem, of course, we know from bureaucracies, as Weber called them, iron cages, is that they end up making the rules of the bureaucracy itself more and more obscure and maximizing the power that that bureaucracy has over the world that it is measuring, managing, and in many cases producing. And it's that last point that I think we really have to worry about with algorithms. Now, because they are so pervasive, they're actually producing the world that they are supposedly measuring. One really good example of this is predictive policing algorithms. So PredPol is the abbreviation of that, abbreviation of predictive policing. So predictive policing algorithms basically say, all right, we want to figure out where we need to send police in order to prevent crime. And so, of course, We feed in all of this data about crime statistics, and then we send police to the locations, to the neighborhoods where crime is most likely to occur. I mean, I'm sure anybody can see already the problem with this model, right? Is that if I send a bunch of police to neighborhood X, there are going to be more arrests in neighborhood X in July of 2022. I'm then going to refeed those crime statistics back into PredPol and say, where do I send police in August of 2022? Well, I'm going to send them to the place where there were the most arrests, right? It becomes a feedback loop. And so effectively, the PredPol system is itself producing high crime rate areas instead of just measuring where high crime rate areas may exist. And there are many ways that we could fix this, right? We could feed different kinds of crime rates into the PredPol system. Instead of feeding crimes about petty thefts or property crimes and things like that, we could feed in data about tax evasion. And let me tell you what, the police would be going to different neighborhoods if we did that, right?
But it's also interestingly, because you've mentioned now twice, the data going into both Compass and PredPol is not actually data about crimes. It's data about arrests. And as we know, in the United States, those are two completely different issues.
I think, as you know, and I know, and Charles knows, but I think most people think that data about arrests is data about crime.
And I think there's a moment where feeding in data about arrests in the name of feeding in clean data, because what else am I going to do, is building into an algorithm which now will operate without human intervention. It's building into that algorithm the mode of operation of the police in relation to, for example, black communities versus white communities. So I think, you raising tax evasion is a really interesting piece of counter data, that if we fed that in, then we would get perhaps a clearer picture about crime. Here, you're pointing to even the ways we don't understand that we're even selecting the data. We think, oh no, it's just data and we're just putting it in. And we don't even recognize the filtering process that we're going through in choosing to put in arrests versus reports, or these crimes rather than other crimes.
And again, that's what Kathy O'Neill calls opinion embedded in code.
It just seems to me that even at the level of sending the police to particular areas, you've already imbued them with the preconception that this is going to be a criminal space or a place where a lot of crimes are committed, because if not, why would you send me here?
Right.
Mm-hmm. Yeah, and we're leaving out, we haven't even talked about facial recognition, which is a technology that's increasingly being used by many police departments, which has its own problems. We know that facial recognition technologies, for example, are very terrible at judging Black people's faces, Asian people's faces. In particular, facial recognition technology is the most discriminatory against Black women. While we're talking about problematic algorithms, maybe I can pick something a little bit less dire in the immediate effects that it has on people's lives, but I think more dire in the broader effects that it has on society in general. And that is the search algorithms that, for example, Google uses, or the sorting algorithms that social media platforms like Facebook, Twitter, and TikTok use. I'm going to use Google because I think it's easiest to demonstrate. I sometimes will invite my students in my class to open up Google and to type in, why should I major in, and then not finish that sentence, right? And look to see what the predictive algorithm suggests for them. And it's always the same thing. So if you type in, why should I major in, the first 5 or 6 predictive words that will come up are business, psychology, finance, science, something like that, right? Now, I say, let's suppose that you are a senior in high school, you're about to go to college, you don't really know what you want to do with your life. And let's say you have a love of the visual arts, you're a painter. And you go to Google and you start to type in, why should I major in painting? But the first 6 suggestions that come up have nothing to do with the visual arts. Now, even if you are resolute in your search and you still type in painting and then you get, whatever the optimized search engine results for that particular question, it's now in your mind that maybe painting is not the best major. Right? And so you could obviously translate this into many other ways that this Google search algorithm, although it seems to be just taking our questions as raw data questions and simply giving us optimal results for those questions, is at the same time, in many ways, restricting the world of knowledge that we can find and restricting the kinds of questions that we can ask.
What's interesting about that is, so I've been for several episodes doing the show notes for this podcast. And often one of us will mention an author or a text or a TV show. And so I want to provide a link to what I think would be the most useful information about that author or text or whatever. And almost always, the first entry that Google will give me is the Wikipedia entry. And that's usually, for our purposes, the least informative. So if we talk about Kant's critique of pure reason, none of the three of us want to send anyone to the Wikipedia page about Kant's critique of pure reason. We want to send them to the thing itself.
We want noumenal answers and only noumenal answers. Wiki noumena.
Oh, I think you may be onto something there.
Would someone's inclination be to just you know what? Rather than read a really dense book that is hard to understand, I'll just read what Wikipedia says about it. And there now my choices of educating myself and having an experience that I otherwise wouldn't have are now diminished. And I think, Lee, you put your finger on the reason why in the name of efficiency. From some engineer's perspective, it's more efficient if I get the quote-unquote answer I'm looking for more quickly, and that answer is most often content, not form.
Well, I wonder if it's also the problem of the democratization of knowledge, because I wonder to some degree if the algorithm says, well, if most people are searching for this particular answer, then in the name of efficiency, then this is the answer that we're going to spit back out to people, because 50 million people can't be wrong about Kant's critique of pure reason. You know what I'm saying?
But I think that what that is evidence of the same feedback loop that I described in the Predpol example, which is that it's not that more people want this answer. It's that I keep feeding people this as the best answer. So it becomes every day a better answer than it was yesterday.
And don't get me wrong, I love Wikipedia for certain things, but I'm not sure that Google should be providing the Wikipedia entry for the thing I'm searching for as its first result.
Well, it's not its first result. The first 7 results are going to be ads.
Right.
People who've paid for you to, when you have this question, to come look at their page.
So what you're saying is I need to develop a clothing line called The Critique of Pure Reason.
Yeah, pretty much. Pretty much. Call us Big Kant.
In the last segment, Charles mentioned something that we didn't really pick up on, and that was the purported objectivity of algorithms. And one of the things I find interesting about that is it seems like one of the reasons we move toward having algorithms, Lee, as you said also on Weber's analysis, this is why we have bureaucracies, is for a very positive reason, namely that we want to eliminate the prejudices that individual humans bring to decision making. And we think that if we have something like a neutral bureaucracy or a non-human algorithm, that will remove those human prejudices. Up until now, we've been looking at the ways in which those prejudices, in fact, make their way back into algorithms anyhow. But I'm also wondering about whether this move toward the objectivity of algorithms falsely equates non-human judgment with justice. In other words, on the one hand, there's the understanding that the reason why we haven't achieved justice is because humans are biased. And on the other hand, it says, okay, so if we remove human judgment from the process of decision-making, the process of sorting, and so on, then we'll approach justice more nearly. And I'm not sure that's in fact the case.
Well, you're right. It is demonstrably not the case. I think you're pointing out something really important here because, I bagged on the Compass algorithm pretty hard in the last segment. But one reason that the Compass algorithm was developed in the first place is because there had been extensive studies done on the prejudices of human judges. It turns out that if you go to traffic court and you get the judge right after lunch or right before lunch, there's going to be a statistically significant difference in the judge's determining of your case. And that's not to count all the other things in the judge's life, whether the judge is actually a racist or a sexist, or whether he likes the color shirt that you're wearing, or whether he had a fight with his wife this morning. And so Compass was meant to provide a more objective assessment of, in this case, the risk of re-offending. But it's just moving the judge further behind the screen, right? That it's still human agents that are designing these algorithms. And the human agents that are designing these algorithms, by the way, are not experts in the law. They're not experts in ethics. And although there have been a lot of moves, and this is hugely important to note because it is a trend that we should all feel very encouraged by. There have been a lot of moves in computer engineering and data ethics to talk about what would responsible AI look like? What would human-centered AI look like? What would explainable AI look like? It's still the case that most people who, for example, go to college and become computer engineers or become data scientists or even become statisticians are not spending a lot of time in ethics classes.
It seems to me that part of what's missing, and I appreciate the desire for greater efficiency, I appreciate the desire for objectivity, I certainly, based on personal experience, can appreciate the problematics of a biased traffic court judge. Let's just leave it at that. But it seems to be what gets missing in the quest for efficiency and clean lines of movement to answer these very complex questions is what I would call a process of justice. The negotiation, the debate, the consideration, the contemplation. Maybe justice should not be a nice, smooth, clean process. Maybe it should be rocky and jagged and maybe a little conflicted. And algorithms just remove all of that. The messiness is important as the result.
Algorithms purport to remove all of that.
Purport to.
They don't actually remove all of that.
Important amendment there.
Yeah.
Charles, in what you were saying, I started thinking about the ways in which various ethical theories, I guess, or positions about ethics, and so I mean things like deontology or virtue ethics, utilitarianism, that in many ways they function as algorithms. That is, if I want to know what the right thing to do is, I put this into the algorithm and out comes the correct answer. And what I hear you saying is that the good, the right, justice never works so cleanly that way, that there will always be this necessary, ineliminable moment in which I have to understand, is this the thing about which this rule applies? For example, if I go to the doctor and she tells me my cholesterol is high and she says, you just need to cut out red meat from your diet. Okay, right now I can go to the grocery store and since it's all in packages, I could see if it's red meat or not red meat. But if I'm just looking at animals, the rule, the algorithm, don't eat red meat, doesn't tell me, is this chicken red meat or not? What about this duck? What about this beaver? So I still have this moment.
Do you have beaver in your grocery store?
Humboldt Park, baby. Humboldt Park.
The reason I mentioned beaver is because you were mentioning my grandma's recipe, and I was handed down my grandma's copy of The Joy of Cooking, which has a recipe for squirrel, has a recipe for beaver. By the way, if you find yourself in the wilderness and you need to eat something, go for the tail of the beaver. It's where you'll get the most calories for your buck.
Pro tip. Thanks, Rick.
Another public service announcement from Hotel Bar Sessions. The point is that there is always going to be this moment where I'm going to have to make a judgment. is this the place to apply the rule or not? And once the algorithm takes over, we've removed that moment of judgment that might be a better way to achieve the justice we're after than having these algorithms perform it for us.
But I want to caution us against having too much confidence in human judgment. In many cases, the reasons that algorithms are instituted is exactly as I was saying before, the reason that bureaucratic structures are instituted, which is to regularize, objectify, in this case, mathematize really important decisions that have to be made. So there was a recent book called The Ethical Algorithm written by Michael Kearns and Aaron Roth. And one of the really interesting things that they talk about is how it's very hard to mathematize concepts like justice and fairness. It's hard to mathematize a lot of these things that we've been talking about today, but one of the examples that they gave that we have made some progress on, or computer scientists have made some progress on, is privacy. So in the last 10 years or so, we realized that a lot of these so-called anonymized data sets were not, in fact, anonymous. As a matter of fact, something like 98% of anonymized data sets can be de-anonymized, down to finding the very individual person that is supposedly anonymized in the anonymous data set. So one of the things that they said is that we can't mathematize concepts like privacy in too strong a terms, like saying no harm will come to anyone who is involved in this study as a result of whatever the study finds. That's too strong of a notion of privacy and would also prevent really important research from being done. But we don't want it so loose that things can be de-anonymized as easily as they currently can be. So they invented new ways of writing algorithms that made it such that, for example, if a study is released and you can be de-anonymized as one of the participants in the study, that no more harm will come to you than would have come by the study being released without you being de-anonymized. Does that make sense? The example that they give is the study that links smoking to cancer. So you could say if you were one of the participants in the study and it came out that you were one of the participants in that study, some harm could come to you as a result of that study being made public. But their argument is no more harm is going to come to you than would have already come to you by that study being made public without you being a part of it.
Yeah, so to just play out what might be a missing step there, my insurance rates might go up as a result of being a smoker, but that's not more harm that they know it's me that I would get than if, as a smoker, they don't know it's me, and yet they'll still come to me and say, okay, your rates are going up now.
Exactly. And so Kearns and Roth are arguing that this is a more robust, a more ethical sense of privacy that can be written into algorithms, that algorithms should be written in such a way that they protect privacy, but not with such extreme definitions that it would prevent important research from being done. Okay, so that's what they say about privacy. And they're like, look, we're making a lot of progress on privacy. I think probably most people who use the internet would say that we're not, but we are. Now, that's a lot harder when you start saying, okay, how are we going to write fairness into algorithms? How are we going to write justice into algorithms? How are we going to write an appreciation for inclusion, diversity, and equity into algorithms? I mean, we can't even write them into department meetings, right? So this is one of the things that we really have to think about is what does it mean to design ethical AI now, to design ethical algorithms? Even if we somehow were able to have a matrix-like way of implanting computer coding into every ethical philosopher's brain, even they would not be able to agree on how to write ethical
And
code.
I take, Lee, your caution. I didn't mean to insist that human judgment ensures justice. And what I take from your last point is that there are good reasons for having algorithms, reasons of efficiency, but also reasons of eliminating bias. And that one area we should focus on is ways of ensuring that algorithms don't include the biases of the writers of the algorithms. And also then could have certain values that the algorithm will not violate. And that this is a messy business, but that it's messy doesn't mean it's not worth pursuing, right? There's a moment here where I think complication comes up against computer scientists' drive for ever-increasing efficiency and therefore reduction of complexity.
It is absolutely essential that we keep working on the front end, designing more responsible, explainable, ethical artificial intelligence systems and algorithms. I think that is absolutely important. But there is a shit ton of work that we can do on the other end as well. And that's where I would like to talk about what I think is a more important move that we have to make, like yesterday, which is that we have got to start instituting some legislation about algorithmic audits. Algorithmic audits should be as essential part of major corporations as tax audits are. And I realize even as those words are coming out of my mouth that tax audits are not actually that essential part. But you get what I'm saying.
What country are you living in? Okay.
Yeah, right. Sorry. But this is an argument of Cathy O'Neil, again, in Weapons of Math Destruction and many other people, is that when we're talking about companies that are using algorithms that have such widespread and significant impact on people's lives, A, they should not be able to have proprietary algorithms. And B, there ought to be regular algorithmic audits done by independent organizations. I think that this is something everybody can get behind. And interestingly, and I actually made this argument in season 1 of Hotel Bar Sessions, that means we have got to get off of the privacy boat and onto the transparency boat. So as users of the internet, of apps, of the current justice system and banking system, et cetera, we need to stop jumping up and down about our own personal privacy and shift the focus to demanding that these corporations, these banks, these police systems, et cetera, be transparent and auditable.
I, for some years, have been an advocate of and involved in free software, free in the sense of non-proprietary. So in the movement, they often say free as in freedom, not as in beer. And one of the main arguments for free software, sometimes it's called open source, and there are reasons why advocates of free software don't want to use the phrase open source. I'm not going to get involved in that. But one of the main arguments for free software is precisely what you're saying, Lee, namely that even the operating systems we have on our desktop computers, on our phones, in ATM machines, and so on, all of these are making a series of decisions for us over which we have no control. But forget about control for a moment. We don't even know what the decisions are that are being made, and we have no possibility of peeking under the hood and seeing what decisions are being made.
Yeah, and just like bureaucracies will resist with their dying breath transparency, so will algocracies, right? And this is basically the argument of Frank Pascal in his very excellent book, which I recommend to everyone, The Black Box Society.
Hey, we couldn't hear you while you were shouting into your headphones. So if you have feedback or suggestions for future topics, or if you just want to pick a fight with one of our co-hosts, or in fact all of us, just visit us at www.hotelbarpodcast.com and click on the interactive page. If you want to belly up to the bar with us, at least virtually, you can always email an audio clip, keep it under 2 minutes please, to hotelbarpodcast@gmail.com. If it's interesting, we're going to steal it from you. If it's not, we'll send you our Venmo handles and you can virtually buy us a drink.
Is this technology raising new questions, or are we still dealing with fundamental primary questions of philosophical consideration just in a new wrapping with a new type of technology? Or is it both? So are we still wrestling with original ideas about subjectivity or privacy or justice, as we were talking about previously? Or has this new technology, has this new way of trying to organize the world created a whole new field and a whole new set of questions?
I love this question. And I think in many, many, many ways, the moral and political and social and economic problems raised by these new and emergent technologies are age-old problems. But I think that they're bringing new ones with them as well. And I think the problem with the new problems is that unlike, for example, television or toasters or indoor plumbing, I think most human beings understand at least what the new technology is. And I think that's not the case with artificial intelligence and the engines of algorithms.
A point I've heard you, Lee, drawing throughout this conversation is the ways in which algorithms are both pervasive in our lives, but also invisible. And so we are engaging algorithms and engaged by algorithms in ways we're not even aware of. And therefore, it doesn't cause our ethical vision to be focused because the thing it should be focused on, in fact, is invisible.
Or even in the recognition, there's a misunderstanding of what exactly is happening. Right. Once again, germ theory in medieval France.
Yeah, I mean, I think the flip side of that as well, though, is that despite the deficient digital literacy of the average person on the street, it nevertheless is the case that increasingly people assess and evaluate and make decisions in their own lives algorithmically. I say this a lot, but people worry about AI becoming conscious and like the Terminator destroying us all. People worry that computers are becoming too human-like, and my worry is that humans are becoming too computer-like and not computer-like in a sophisticated way.
Right.
Calculator-like.
It seems the greatest trick that algorithms ever pulled was to convince you that they don't exist.
This actually goes back to a point Charles made, I can't remember what episode, in which he raised how good the algorithm that Pandora used, they called it the Music Genome Project, to deliver music to you based on your taste. Now, because this isn't a transparent algorithm, my experience of it is that they changed it, and they changed it for the worse. And I don't know why they changed it, but it's delivering less sophisticated results, I think, than it used to. But there was a moment in which the algorithm, I think, was delivering pretty much what it promised and what we wanted. Namely, I want to discover music I don't know about that's like the music I like. So it was really good at bringing unknown artists to your attention, and I think it's become less good at that. But in a way, it's never been as good as when I walk along my 1,000 LPs, and I'm like, you know what?
Right.
I didn't know I was in the mood for Peggy Lee, but there she is, and I'm going to listen to Peggy Lee now. And I think one of the ways in which now we become more algorithmic in our thinking is that things like choosing music and listening to music is now, I think, a completely Pandora, Spotify, name another service like this, experience, and less the experience of choosing an album, a serendipitous thought I was in the mood for Bach, but it turns out I'm in the mood for the Sex Pistols. That kind of thing that belongs to our engagement with the world, now that it becomes more and more algorithm-like, I think becomes a kind of impoverished experience.
Yeah, because it's leaving out another kind of serendipity that Spotify can't give you because it's a reinforcement algorithm. It's based on reinforcing tastes and preferences that you already have. It can't give you the kind of serendipity of going over to someone's house and literally hearing music that you've never heard before, hearing something that's not even like anything that you've heard before. We all remember walking into a library and just wandering around in the shelves, right? I'm going to find out that, for example, there's this book on beavers, and I'm going to learn that the beaver tail holds the most calories only because I had to pass the beaver section on the way to Kant's Metaphysics of Morals.
Yeah, I mean, what you're calling serendipity, I think to myself, a sloppiness about discovery that's getting lost. And to me, instead of Pandora or Spotify, it's walking through a record store and just randomly looking at titles and picking up covers, turning them over, seeing who produced this, who are the musicians on this, and based upon that sloppiness, that inefficiency, if you will, something really amazing gets discovered. And all of that's getting lost.
I like that example because when you're in the record store and you select a record because you like its cover and you listen to it, that has nothing to do with your musical tastes. That's a decision that is, in many ways, almost impossible to turn into an algorithm.
It seems to me that what Lee and I were calling serendipity and Charles calls, in a positive way, sloppiness, is part and parcel with what it is to be human. And so either the pervasiveness of algorithms are forcing us to become more algorithmic, or algorithms reduce that serendipity and sloppiness, moving toward a human experience that is a reduced set of the possibilities of human experience. And I think that's an ethical problem in and of itself.
Well, it seems that Noel's algorithm is calling for us to get the hell out. I think we can have one last thought about this. And I want to say this has been a great conversation. I've learned a lot from both of you. This has not alleviated any of my concerns or doubts or anxiety about the role of technology in our lives. I'm coming away thinking that the road to hell is quite an efficient one.
It's optimal.
But Lee, any final thoughts on this?
Yeah, I just want to follow up on something that Rick said at the end of the last segment. He didn't use this term, but he mentioned a more human-centered way of thinking about artificial intelligence and the algorithm engines that drive it. And this term, human-friendly or human-centered AI, is actually a term that's getting used a lot now in the debates surrounding ethical algorithms, ethical AI. And it assumes correctly that statistical models are commonly assessed by metrics that balance their accuracy with their complexity. So you want a model that has the most amount of explanatory power with the least amount of dials that need to be turned, right? Like that's the best kind of model. And human-centered AI or human-friendly AI is asking a different set of questions. They're like, can we imagine a more human-centered metric that does reward things like what we were describing in the previous segment, a kind of limited bewilderment or wonder or whatever when probing and testing that model? That is an important thing to keep in mind, that there's still a lot of tinkering to be done with these machines. The other thing that I will say, which I already said, but I can never say enough, is that we have got to get some legislation about auditing algorithms. Sing,
I'm
song.
sure 89-year-old Charles Grassley from Iowa is going to get right on that.
Oh, God.
So before we call it a night, I want to invite our listeners to support us on Patreon. You can find us at patreon.com/hotelbarsessions.
So I already got us a ride using my handy-dandy Lyft app because Uber sucks. And it looks like I've got the most optimal and efficient way home. Anybody want to ride with me?
I'm going to take the sloppy way home.
Shotgun.